All right, so I think we're just gonna begin now. So if you guys can check your chat, I'd first like to ask everyone to please keep their mics on mute and please keep their video cameras off throughout the duration of the webinar. If you happen to have a question during any section of this webinar, please post your question in the chat. One of my colleagues, Colin Lee, one of our other engineers, is going to be trying to answer your questions in the chat. If your question is a little, maybe a little specific, it's kind of difficult to answer through the chat, we're going to have a Q&A section at the end of the live demo. And we're just going to go one by one on the posted questions that we couldn't answer during the chat room. Okay. Okay. Yeah, so let's get started. Again, my name is David Martinez. I'm an applications engineer for Solomon USA, based out of our Los Angeles office. And today we're going to be discussing how we set up a real-life application. It's been in production for about a little over a year now. It got installed last October. It's for Mergon. They are a plastics manufacturer in the automotive, industrial, and healthcare industries. And essentially, the task for the cell is just to mount some clips onto a plastic mold. So these are the clips right here. They're pretty small. They're quite shiny. And they have two different sides. So there's a top face and a bottom face. And they have to be placed onto the mold in the same orientation every single time. This is the feeder system, how the clips are fed into the bin. And as you can see, there's a shaker system installed as well. In this cell, we are interfacing to a PLC. So AccuPick, the software we're going to be discussing today, our 3D bin picking solution, is sending pick coordinates directly to a PLC register. And then the PLC register is sending those to the robot. And they're handling the robot motion themselves. So here we pick one of the clips. I have a video here that goes a little more in-depth in the full process. So here's a kind of a more full bin full of clips. We're going to pick two of them. You see these second stations here. We're going to be placing those clips onto the second station because they need to be picked up again in a different orientation to be able to be placed onto the plastic mold. So we place one. If you notice, every time we pick, we're taking a scan as the robot moves out of the way. That's a little bit hard to notice here, but that way, whenever the robot comes back, so there was a scan just there. Every time the robot comes back, there's already a pick point ready, so there's no downtime. And we have a lot of time in between picks, so cycle time for the vision system is not a problem. We can be as accurate as we can. So there we've just placed one of those clips onto the mold. We're going to be picking that mold up. And then right here, there's a second camera just to have as a final check to make sure the clip was placed correctly. And then we just drop it off once it's done. On the next mold, you'll be able to see a little bit better how the clips have to be placed onto the mold. Let me just fast forward here a little bit. So the clip is right here. That's how it needs to be placed. It needs to be placed like this every single time. So we're going to be discussing today how we set that project up step by step. Before that, I just want to briefly go over our company profile. So Solomon Technology Corp was founded in 1973. We've been listed in the Taiwanese stock market since 1996. You can see our revenue there in US dollars from 2018. Our business scope includes machine vision, robots and cobots, energy solutions, and many more. We have a lot of offices worldwide. We're mostly centralized in Asia, so in China, Southeast Asia, and Taiwan. We are headquartered in Taiwan, but we opened a U.S. office here in the Los Angeles area about a little over a year and a half ago. And we very recently opened an office in Detroit, Michigan. So here's the Solomon Global Network. You can see a lot of our offices are located in the Asia region. And we are planning to open an office in Europe in Q1 of 2021. So we have constant communication between our offices. So we have a lot of experience worldwide in a lot of these kind of bin picking solutions. And these are going to be the 4 AI platforms that Solomon offers. Today, we're going to be discussing AccuPick, which is our solution for random bin picking. We also can provide Sol Motion, which is AI vision guided robotics. So we guide the robot using AI technology. Sol Vision is our 2D AI inspection software. And Sol Scan is the last one. That's going to just be the scanner. So if you need to render, an object with, you render a point cloud of an object, you can use our 3D scanner based on structured light technology. And so this is just a graph of how our AI 3D vision software works and interfaces with different hardware. So you can configure different hardware and use it with our software, right? So you can see there that we are compatible with pretty much all the leading robot and cobot brands. These are the PLCs that we can interface with as well. And if you notice on the bottom left, we're actually compatible with different kind of 3D camera technologies, whether that be our own structured light camera, Intel RealSense's active stereo vision, or a Microsoft Kinect time-of-flight cameras, even some laser scanners, right? So you have the flexibility to use a lot of these different hardware systems in conjunction with our software. This is going to be the AccuPick data flow for today. So we are running AccuPick on a Windows-based PC. That PC is the camera is connected directly to the PC. And right now I'm running an Ethernet directly to the robot controller. In the production line, in the real case, we were actually connected directly to a PLC, and we are just updating PLC registers with the pick coordinates. But in today's example, we are going to be controlling the robot movement directly through AccuPick. All right, so let's get right into it. So this is the beginning of the live demo. Again, if you have any questions during this process, please post them in the chat. So when we open up AccuPick, this is going to be the first screen that we see. We're going to be coming back to this screen later. This is where our results are going to be shown. The first thing I want to do is I want to log in. AccuPick now has different user level access controls. So by default, I'm logged in as a guest, and a guest cannot change any settings or adjust any process flow. They can only check the results screen. So I'm going to log in as an admin, my password. And then what I want to do is I want to click this button up here. And so now I'm at the flowchart. And the flowchart is where we do most of our work. This is where we can set up how our process is going to flow. So if you can see, I have a lot of different blocks set up. So I'm going to go through them one by one so you can understand just the general process. So the first block here is the capture block. That means I'm going to take a 2D and 3D image. Next is the recognition block. That means I'm going to recognize the items in that image. I have a bin config block. I have a bin config block, which I'm going to set up a bin virtually in my 3D point cloud so that I know when I recognize the objects where they are in reference to my bin wall, so I don't cause collision. This filters block here is so that I ensure that I only pick the best objects first. It's quite important because for this, these parts are quite small and quite shiny. So sometimes the point cloud does not produce a good enough pick point. So we just have to make sure that we pick the best items first. I'm running that off to an if-else block here. I set up a condition where if the filters block outputs a pickable part, I'm going to run my PickDrop mission. And if it does not output a pickable point, so let's say there's no pickable items in the bin, I'm going to do a shake mission for the robot. Now, we don't have a shaker here installed, so the robot's going to do a mission to let me know to go shake the bin, so I'll be the shaker for our system today. And for now, I'm just running those off to an end block, so we're just going to do one run, and then we're going to stop.
Colin, we're unable to see your screen. It's still on the PDF.
Oh, sorry. Okay, can you guys see my screen now?
Yes.
Okay, sorry about that, guys. Let me just start over here. So this is going to be the AccuPick screen when you first open up the software. Like I mentioned before, this screen is just to see the results. By default, when you open up the software, you're logged in as a guest. As a guest, all you can do is stay on this screen. You can only see the results. You can't change any settings, adjust any parameters or anything like that, right? I've already logged in, so I'm logged in as an admin. I just logged out, so I'm going to log in again. You can set up your own passwords for the different user levels. So now what I want to do is I want to click this button here to go to the flowchart. So I'm going to click it, and here's our flowchart, right? So it's easy to see the process that we're going to take. I'm just going to go over it once again. It's set up in different blocks. So first is the capture block. I'm going to capture 2D and 3D information. Recognition block, I'm going to recognize objects in that 2D and 3D image. My bin config block is where I'm going to set up my virtual bin within the point cloud. This is going to be useful later on for collision avoidance. This is my filters block. This is where I make sure that I only pick the best objects first, which, as I mentioned before, is quite important in this case. And I'm running this off to an if-else block. And so the condition here is if the filters block output a pickable object, I'm going to run my pick and drop mission. If, on the other hand, it doesn't output a pickable object, I'm going to run a robot mission to just let me know to go shake the bin. If you notice in the video, in the real scenario, we have a shaker system installed. So let's just begin at the capture block, right? We're going to be configuring the system one step at a time. So we're going to start a capture. To open up the block, we want to click the settings tab. And so it opens up this page here. This is where we can connect our cameras. Right now, we're using one of our Solomon structured light cameras. I'm going to connect it here. Okay, so our cameras are connected. This is the camera view. And if I zoom in here, you'll see the clips themselves. So for the purposes of today's demo, in the real situation, actually, this is going to be the top face, and this is going to be the bottom face. So we're going to be doing two classifications, one top and one bottom. It's kind of just arbitrary which one is top and which one is bottom. That's just what we agreed upon. And here in the camera settings page, we can set up different. We have different controls, right? So we can change exposure time. We can change digital gain and or gamma. So my goal here is just to have the clearest 2D images possible, which for me right now in this environment looks pretty good. So moving on to pattern setting, let me take a 3D scan just to show you the structured light pattern here. These lines that you see here is a structured light. We are using pattern quality high. I will show you what pattern quality medium looks. Medium works for a lot of cases. In this case, it might not though. Let me just show you. So when I take another scan, you'll notice that the lines are much thicker, much broader. So we get less lines per part because they're so small, right? So for this case, we kind of have to use pattern quality high to get the best possible point cloud. So now we see that the pattern lines are much thinner. We get much more per object. Okay, so now we configure the pattern. Now I want to connect my robot. So for the purposes of today's demo, we're going to be using a UR10 robot. And here are the different robot brands that we can connect directly to AccuPick. So I've set up my PC IP, robot IP, and I have my TCP position here as well. To connect the robot, I'm going to click this button here. Once I connect, you see all the position information updated along with the joint positions for the UR. So moving on to the calibration setting, this is where we calibrate the camera and robot system. I've already done this to save us some time. It took me about 15 minutes. I will share with you the process that I took to do it. So I've recorded a video here of the calibration process. I'm going to play it. So basically what I've done is I've mounted one of our Solomon chessboards onto the robot arm. And I'm just moving the robot arm with the chessboard mounted in different positions inside the field of view, taking a camera image every single time. So every time we take a camera image down here, you'll see the camera image update. We are referencing where the chessboard is in relation to the camera, and also at the same time recording the robot position. So using that information, we can get a calibration to calibrate the robot and camera system at once. Here we see our error. So translation error in X, Y, and Z. So it's a little over 1 in X, less than 1 millimeter in Y, and less than 1 millimeter in Z, which for this project is well within threshold. This is our rotation error, which is all quite low. These are in degrees. So that's how we calibrate the system. I'm going to be moving back to the AccuPick screen now. And so now that we've calibrated the system, the last thing we want to do is make sure that our point cloud is at the best quality for the parts. So if you notice in this image here, I have a blue kind of bounding box around my bin. Basically, I've set this up so that I don't capture any points out here. I'm not interested in anything outside of the parts inside the bin, right? So I don't need to waste time to render or process any of the points out here. Now, if I move on to the 3D point cloud, this is the point cloud itself. You can see the clips in here. You'll notice that it's actually a little bit noisy. This is because the clips are kind of shiny. So we just can't avoid some of the noise here. But I'm doing some post-processing within AccuPick to try to get the best possible point cloud for some of these parts. And you'll notice that some of these clips, like for example, this one, it's pretty clear. There's no noise on it. It looks pretty flat. It's well defined within the point cloud, so we can generate a pretty good pick position there. So now that I'm done with this, I actually can minimize the capture block right here. So I've set up my capture block. Moving on to the next step is the recognition block. So I'm going to open that up. So I'm going to do just one recognition scan here just to update the image here. All right, so we see this image. And then you'll also see that there's kind of this red bounding box around the bin. That's our ROI, or region of interest. And if I make this bigger, you'll see more of the image gets displayed, right? So basically what I'm telling it here is only recognize parts within this box. Since again, I'm only interested in picking up parts inside the bin. And this is actually kind of important because in the real case on the production line, sometimes the clips can actually fall outside of the bin, and sometimes there's a lot of clips just laying around on the floor. So we don't want to be, recognizing those or trying to pick those. So we just kind of set up different bounding boxes to make sure we only pick items inside the bin. So moving on to our AI method tab here. This is actually where we can train our objects. This is where I'm going to train the AI what a top class is and what a bottom class is. We have many different tools within AccuPick that come in with standard AccuPick. Today, we're going to be going over the instance segmentation tool, which is what we're using in the production line as well. So first thing I'm going to do is I'm going to click this camera button here and take a camera image. So I'm just going to take an image here. I'm going to go back to my tool, and you'll see that image is updated here in the input tab. I'm going to right click, add to the training list. I'm going to move on here to the annotation tab. And then here you'll see a lot of different images that I've taken previously. This is to save us some time. I've done 16. So 16 total images. And basically what I need to do is I just need to annotate what my top and bottom classes are. You'll see I've created two classes here, top and bottom. And I'll show you the process of annotation. So right now, for example, this top right here, I'm going to use our polygon tool. We have many different drawing tools. For this case, we're going to be using the polygon tool. And pretty much what I want to do is I just want to outline the feature that I want to the AI to detect. So this is going to be my top face, which is that flat area. And I'm also going to be adding a reference angle. So this angle is here so that I can pick the part up in the same orientation every time, which means I can drop it off in the same orientation every time. So I'll just do a few here. Since we've installed this project, we've come out with a new tool called the auto labeling tool. So if you provide us a CAD model of the part, unfortunately we don't have it for this part, we can automatically label your part. So the process that I'm doing now can be avoided. It'll be automatically done through a separate software, which saves a lot of time. Just as reference, it took me maybe half an hour to 40 minutes to label all these 16 images here. For bottoms, my orientation angle is going to be this way. So this is the process that I did for each image. You'll notice there's a lot of different parts annotated in each one. And again, with the auto labeling tool, it'll automatically generate these different images and the different part annotations. And so once I'm done with this, let's say I've annotated all my images, I move on to this model tab. This is where we do the deep learning. For the deep learning, we pretty much just have to let it run for about 20 minutes. Again, I've done this already so that we can save some time. But pretty much we click the start button and we just let it finish. It takes around 20 minutes, maybe a little bit more, 30 minutes at most. And what it's going to do, it's going to go through each image and learn each annotation, right? So it's going to learn what a top looks like, what a bottom looks like. So then it can make decisions and recognize them. So once we're done with our deep learning, we just want to check that our AI model is good. So I'm going to click this in my validation list. I'm going to click this play button. And what it's going to do is going to start detecting all the images. So if I click on this, these are all the different annotations. So these are detections that the AI has produced, right? And right next to each class, so we can see it's looking pretty good. The tops look correct, the bottoms look correct. So does the reference angle. You can notice right next to the class name, there's a score or a number, 1.00 in some cases, or sometimes a little bit less. That's the AI's confidence score. So if it's 1.00, it's basically telling us I'm 100% confident that that is a top. And so we can use that score to kind of limit what parts we want to pick up. Let's say we don't want to pick up anything less than 90%, because you always want to pick up the best objects first, right? We can set something up like that. So just going through my images here, it's looking pretty good. So now that I'm happy with my recognition, I can move on to the matching method section. So I'm going to click here. If you notice, there's already some parts being recognized with pick position. If we go to object type here, I'm gonna show you top first. So these are different tops in the bin that we can pick. You'll see the pick point generated on each one. And the matching method that we're using here is called plane fitting. Luckily, if you notice on the top parts. Let me show you a top here. So this top right here, let me increase the point size so you can get a better look at it. This top right here, if I move around, you can get a better sense of the shape of the object. It's pretty flat. Luckily, it's pretty flat. It's pretty planar. So we can use one of our, Solomon has created some catch-all matching methods. So we're using one called plane fitting. It matches the part to a general plane. Luckily, you can also use that for bottom class as well, because the bottom classes still have a flat section on the surface, which we can match to a plane. Now, you might ask yourself, well, what if the part isn't as simple as this, right? Or like if it's more complicated? We have different matching methods. So we have some sphere fitting, which is just a catch-all for any spherical object. Cylinder fitting, which you can use for something like screws, for example. And if your part is more complicated, we can use something called matching 3D, which is where we use the CAD model of the part, or we generate a model out of the point cloud itself and use that model to match, to do the matching 3D. So for more complicated parts, we would use this setting here. But luckily for these parts, we can use top and bottom. We can use plane fitting for top and bottom. And the important thing I want to do here, let me just show you on top, is I want to make sure that my orientation is the same. So if you'll notice on the top shapes, the X axis is always in the same orientation. That's because I'm force rotating it along that same angle that I taught it here. So this is kind of a reference angle. Let's say for whatever reason you need to pick this up at a different angle, we can offset it. So I'm going to offset it by, let's say, 40 degrees here. And so now that'll be our picking orientation. All right, so now that we've set up our matching method, we have one more tab here called TCP setting. This is useful if, let's say, we were using more than one tool, like we were using one tool to pick up tops and one tool to pick up bottoms. That's not the case here. We're only using one suction cup. So for now, we are not going to be using these settings here. So we're done with our recognition tab, right? So we're done with recognition. We can move on to the bin config, which is where we're going to set up our bin. So first, I want to click this 2D image here. You'll see this image. Let me just make this a little bit bigger so you can see a little better. Okay. So here, what I want to do is I just want to create my bin. I'm going to be clicking on the inside corners of my bin as best as I can. You'll see this line show up. You can drag it out and then click on the other end and then create a square bin like this. Now, if I move to the 3D section and I show the bin, you'll see the bin here. So that's our bin within our point cloud. You'll notice the bin is too high. The bin actually extends to this little sliver of base here. I left it in there on purpose so I can make sure that I get the bin depth correctly. So I'm going to pick a point there. We'll see that the depth is at -30 millimeters in Z. So I'm going to adjust the bin center to -30. It moves our bin down. Then all I need to do now is just adjust the depth to something that's reasonable. So let's just say something like that, right? So that's going to be our bin. I can adjust the rotation of it as well to align up more, but this works for us right now. So we're going to be using this bin later to set up some collision avoidance. I'm going to click this get button. You'll notice it updates some of these values here. And so now our bin is set up. So we are now done with the bin config block. And now we finally are going to move on to the filters block. Now this block is quite important. This is where we make sure we pick the best objects first. I'm going to start with the top class. So you'll notice that some of these recognized parts are green and some of them are orange. If it's orange, that means that part has been removed due to not passing some threshold that I've set. And if it's green, that means it's a good part, it can be picked. So if I click on some of these parts, you'll notice that when I click on it, we get a lot of information here. We get object angle, deep learning scores, 2D points and 3D points. So what I want to do is I just want to check each one and just kind of check to see which parts are looking like good picks, which one are looking as bad picks, and use those scores of each part accordingly to set up my thresholds. So you'll notice here this orange one. The area 2D is out of range because the 2D area is 1206, so 1206. That's below our minimum threshold value. So using all these, this is kind of the fine tuning section now. So using all this different data for each object, we can set up object filters to only pick the best parts. So I've done the same for bottom. So you'll notice there are some green ones and some red ones and some orange ones, excuse me. Yeah, so here is just where we just kind of really key in which points we want to pick, which parts we want to pick first. So the setup here is very similar to the real case. And so now I just want to show you the collision avoidance system that we have here in AccuPick. Right, so if you guys can see the live camera screen here, you'll see that our suction cup, we're just using a very simple suction cup tool. It's pretty much just a rod with a suction cup fitted to the end of it. It's pretty much a cylinder, right? So I'm going to use the cylinder tool. I could use the CAD model of the tool if I wanted to as well. So that's also available. And I've set up my radius and my length. Now, if I go to the 3D view, you'll see that now it's just highlighted all the possible pick positions in this bin, right? And if I click Show Tool, you'll notice that these kind of blocks show up on top of the pick positions and also the bin that we set up previously. Now, if any of these rods cross the plane of our bin, that is a collision. So the object corresponding to that rod is a collision object. It's going to be removed until it's physically moved to another position. For now, I'm going to turn the Show Tool off. And if you notice here, in objects per scan up here, it's set to 29. This means that for one scan, I'm going to try to pick up to 29 objects at once. I'm going to set this down to 1, which means I'm going to pick one object per scan. In the real scenario, when we pick an object, sometimes it moves a lot of objects around it. So we don't want to kind of pick an object, even though it's not in the same position it was when we scanned it. So this way, and we have a lot of time in between picks, so it's okay for us to go one at a time. All right, so now that I've set up all these blocks here, right, this is pretty much the AI and the pick settings done. Before I move on to the RobotScript and if-else blocks, I just want to show you how we would set this project up if we weren't going to use AccuPick to control the robot. So let's say the robot was going to be sending commands to AccuPick, and all we were going to do is provide the robot with the pick coordinates. So what I want to do is I want to add a separate block. It's called the protocol block. I'm going to link start to protocol, protocol to capture, and I'm going to loop filters all the way back to protocol. I'm going to open up this protocol block now, and you'll see we have a port number 10,000. That's default. We can set that port number to whatever we want. I'm going to leave it as 10,000 for now. And what I want to do is I want to add a flowchart command. What that's going to do is it's going to link this protocol block to the capture block. So I'm going to click the drop down. You'll see the capture block is right here, ID number 3. You can see the number 3 right here. And I'm going to set up a command string. The command string can be anything. I'm going to set it up as run. So when the client server sends run to AccuPick, AccuPick is the server, server. We are going to continue the flowchart. So I'm going to open up this simulation program. It's called SocketTest. You can see my port number 10,000 set up right here. I'm going to connect. We get a welcome Solomon, which now we know that we're connected to AccuPick. Oh. Excuse me, guys. Let me share you the screen here. Okay. So this is SocketTest. This is the simulation for client-server communication through TCP/IP protocol. I'm going to connect to port 10,000. First, let me clear this. When I connect, you see a welcome Solomon. Now I'm going to send the start command to initialize my flowchart. You'll notice I received start back and a 002. A 002 is our feedback code for success. So the command was received and performed successfully. Now I'm going to send that run command that I set up. So when I click run, now it's going through the flowchart. So you'll notice the camera might scan, is recognizing, and then I receive a 002 back. That 002 means that there's objects ready. So I'm going to send the command get object info. And we receive this string. So we receive the command get object info along with all our pick coordinates. So these are our pick coordinates here. These are going to be the pre-target and target pick coordinates. And this 1 right here is going to be our class ID. So this 1 means that we're going to be picking a top, and a 2 would be a bottom. So using this string, you can use the robot language to parse through the string and extract the pick coordinates and set up some variable positions inside your robot mission as your pre-target and target coordinates. The process for using a PLC is extremely similar, except that instead of sending it as a string, it's instead just updated into some PLC registers, and you can input those coordinates into the robot as well as variable positions. So this way, we don't need to connect the robot to AccuPick at all. You can handle all the robot missions yourself. And you basically just send commands to AccuPick and check their statuses, and we just provide you the pick coordinates. All right, so for now, I'm going to disconnect from here and move back to the AccuPick screen. Okay. So I'm going to set the flowchart up as I had it before. So I'm gonna go from start to capture, and from filters to if else. Delete this one. I'm just gonna delete this protocol block. Okay. So like I mentioned before, the if else block is here just so that if I get pickable objects, I run my PickDrop mission. If I don't, I run shake. I'm gonna show you the PickDrop mission here now. This is going to be my robot action. I have a start pick mission and 2 drop-in missions. If you notice in the live camera view, we have 2 blue bins. One of them is going to be for bottoms and one of them is going to be for tops. So setting up missions in AccuPick is pretty simple. Any robot that we can connect to AccuPick, we can set up the same way. So for example, let me go to my start pick mission. Through this interface, we can move the robot. So if, let's say I put a 20 here, I can move the robot in X and Y, up or down. And I can move each joint. And for some robots, for example, for UR, we can actually enable free drive from AccuPick as well. So to set up missions, we have a move function, which is setting up a waypoint. So this is the waypoint. This is the position that the robot is in now. We can set up IO control, and we can set up wait times. So these are going to be the important ones that we have for this mission here. I'm going to go over my mission step by step. So my first mission in start pick moves the robot over the bin. My second mission is going to be pre-target, which is just 20 millimeters above the part itself. Target is where we actually touch off on the part. I'm going to turn on my suction cup. Turn on my suction. I'm going to wait for 0.75 seconds. I'm going to move back to pre-target, and then I'm going to move back to this above the bin position. So that's my start pick mission, pretty simple. Now my start drop in top mission, the first mission is going to move the robot over the first blue bin. I'm going to turn off my suction. I'm going to move the robot down. And then I'm going to wait for a second and move the robot back up. And start drop in bottoms is exactly the same, except that it's over the farther bin. So it's exactly the same motion, so up, down, and back up. So, and we have one more mission, which is the shake mission. This is just a super simple mission. If I run it here, the robot's just going to do that. And when the robot does that, it lets me know that I need to go in there and shake the bin up. Okay. Yeah, so this is pretty much the setup for our demo. So now what I'm going to do is I'm going to loop these RobotScript blocks back to capture. So once it finishes, the RobotScript block is going to just capture an image again. So I'm going to click the start auto run. We're going to take a scan. You'll see the flowchart move through here. And now we're running the RobotScript, right? And we're going to start picking parts. And if I move back to this window here, you'll see the results. So we have a live view, we have our 3D point cloud with the pick positions, and we have our 2D recognition screen. And we can actually save some time here. If we don't update the point cloud, which we're not doing in the real case, the point cloud will just not render. So it's not going to render it in 3D viewport, but it is still updating, but it just saves us some scan time because we don't need to take the time to render the point cloud. This is all we have prepared for the demo today. If you have any more questions, maybe on project specifics or anything, I think one of our sales representatives can share their emails in the chat or get in contact with you, and we can discuss your project more in depth. Yeah, thanks everybody. Everybody have a good holiday season.